Hello, and welcome to Chapter 5. The first half of this chapter will be talking about quality assurance and method validation. And this is an important part of analytical chemistry. We'll touch on this in this chapter. We won't spend a lot of time on it, but if you do go into the analytical chemistry field, these are actually really important questions and ideas to be thinking about. And this is also something to be thinking about if you are designing your own experiment. How do you assure that you're getting quality results that are actually going to be useful to answer the question that you're interested in? So one of the really key points in a quality assurance idea is understanding why you're doing the measurement. It's something I've mentioned before, but this is a really key part. What is the purpose of your measurements? Because if you don't know why you're measuring, then it's hard to know if you're achieving the target that you're the target you're trying to find to be able to answer the question, the ultimate analytical question you are asking. So when we're thinking about this, we need to think about what is the specific aim of the technique that we're using, the measurement that we're doing, and so this really depends a lot on the context of how you're doing the measurement and what the purpose is for. What is the ultimate product that you're trying to produce out of this? Are you just trying to get information to guide a future decision, or is this something that you have to do for reporting requirements, for the government? Is this going to go on a food label? And that changes the level of specificity that you need. And many times, if it's for, say, a government requirement, there are specific guidelines that you need to follow that need to be achieved by your method that you're using. And so when we're doing an analytical measurement, we can define use objectives, which is, I guess, just a slightly different way of saying everything we've been saying before. What is the result of your experiment going to be used for? What's the objective that it's going to be used for? Similar to previously, this makes the most sense when we think about some specific examples. So let's look at a few ideas, examples of analytical measurements and what the purpose might be. So let's say, for example, that we are working in a lab that's doing measurements of lead in water. Okay, and that's a pretty common thing that we would want to do. And the use objective, the question that you have is, does the amount of lead in water exceed 15 parts per billion? And the reason we pick 15 parts per billion is this is set by the EPA. Anything below 15 parts per billion is considered fine, but anything that is above means that your pipes need to be treated because it is an unacceptable level of lead in your water. All right? And so that's now we have a very specific objective we're going for. Does the lead in the water exceed 15 parts per billion? And the question we're trying to answer is, are our pipes okay? Or do we need to treat them to make sure there's not too much lead going into the water? Another example. Let's say that we are measuring iron in food. And the purpose of this one probably is that you would like to determine the amount of iron for proper labeling. Now, the definition of what's proper for labeling is going to come from the Food and Drug Administration, from the FDA. So you have a specific set of guidelines that you need to adhere to. You have a level of specificity you need to know. And you may notice this on food labels if you look at the food labels on things that you buy. that these are usually rounded. So for example, for iron, typically things are rounded to the nearest 5% of your recommended daily allowance, or to the nearest 5 or 10 micrograms or whatever unit or milligrams, depending on which specific nutrient you're looking at. So those are sort of guidelines that you're needing to follow. So you need to determine things to that level, right? And you don't need to know maybe to the part per billion level like you do for the lead in water, right? So the different purposes here mean you're going to have different specifications you need to follow. The final one I'll mention, just because it's relevant this year and for people watching this in future years, I'm sure you'll remember the COVID pandemic. Let's say that you are doing a COVID test. And your use objective here is the person infected with COVID, right? You want to base decisions about quarantine, about isolation, about possible treatment, right? You're making decisions based on an analytical measurement, right? Is there a detectable level of virus present? And for a COVID test, there are specific specifications that are set up to determine whether, with the type of measurement you're doing, and there are different types of COVID tests, right? So the use cases are going to be a little bit different for, say, a rapid test using an antigen versus a PCR test, a polymerase chain reaction, which is a much more sensitive technique, right? So the use case or the guidelines you're going to use are going to vary and what you consider a positive versus a negative. So, these are just some examples of the types of questions that you might be asking in an analytical chemistry context and thinking about what sorts of specifications are going to be part of answering these specific questions.